Okay, for this problem, we're going to solve this third order initial value problem. Y triple prime minus 7y prime plus 6y equals 180t with the given three initial conditions. First off, we find the solution of the homogeneous equation. So r cubed minus 7r plus 6 equals 0. And I have to somehow factor this characteristic equation. So we start off by listing out the possible rational roots. That'll be things that go into the constant term 6, divided by things that go into the leading coefficient, which is 1. So I have 8 possible rational roots to test. Okay, there's no guarantee that any of these 8 will actually work. The only reason that we have to think that any of these will work is the benevolence of your instructor. So let's try it out. 1, 0, negative 7, 6. We don't forget the 0 because there's a 0r squared term here. So we have 1 times 1 is 1, adding 1 times 1 is 1, add negative 7 plus 1 is negative 6, multiply, I get negative 6, add, I get 0, and it factors. Okay, so I have the partial factorization r minus 1, r squared plus r minus 6. And so I can factor that as r plus 3, r minus 2. And so I have 3 distinct real roots of the characteristic equation. And so that means that my homogeneous solution is going to be c1 e to the t plus c2 e to the minus 3t plus c3 e to the 2t. Okay, next we find the particular solution for 180t. So 180t, that is a polynomial. So let's guess capital Y of t to be equal to at plus b. So that is a polynomial of degree 1, and so my guess will be a polynomial of degree 1, and I make sure I don't forget the plus b, even though that there was no constant here on the right-hand side. Okay, so y prime of t will equal a. Then the second derivative is equal to 0, and clearly the third derivative is equal to 0. So let's set up y triple prime minus 7y prime plus 6y equals 180t. So 0 minus 7a plus 6at plus b equals 180t. Okay, so that gives us that 6at plus 6b minus 7a is equal to 180t plus 0. So matching the parts, I have that 6a is equal to 180, and that 6b minus 7a is equal to 0. So this means that a is equal to 30. Over here, this means that 6b is equal to 210. And so dividing by 6, I get that b is equal to 35. Okay, so my particular solution, is equal to 30t plus 35. And so therefore my solution of the general solution of the differential equation is going to be the solution I saw here, c1 e to the t plus c2 e to the negative 3t plus c3 e to the 2t plus the thing I just got, 30t plus 35. And so that is the general solution. Okay, so far so good. Now that we have this, we now have to go back and work with the initial conditions, that y of 0 is equal to 10, y prime of 0 is equal to 0, y double prime of 0 is equal to 0. So let's come back here and let's figure out y prime and y double prime. So y prime of t is equal to c1 e to the t plus, actually let's take the derivative, get negative 3c2 e to the negative 3t. Then I have plus c3, 2c3 e to the 2t plus 30, Also, y double prime of t is equal to c1 e to the t plus 9c2 e to the negative 3t plus 4c3 e to the 2t plus 0. So now let's plug in 0. Y of 0 is going to be equal to c1 plus c2 plus c3 plus 35. Y prime of 0 is going to be equal to c1 minus 3c2 plus 2c3 plus 30. And y double prime of 0 is equal to c1 plus 9c2 plus 4c3. And the given initial conditions were that y of 0 is equal to 10, y prime of 0 is equal to 0, y double prime of 0 is equal to 0. Those came from the statement of the problem here. Okay, so I have a 3x3 system that I need to solve to get C1, C2, and C3. So continuing the problem, we get that C1 plus C2 plus C3 is equal to negative 25. We get C1 minus 3C2 plus 2C3 is equal to negative 30. And C1 plus 9C2 plus 4C3 is equal to 0. So I have a 3x3 system that I need to solve. And the way that I'll do this is with an augmented matrix. So 1, 1, 1, and negative 25. 1, negative 3, 2, negative 30. And 1, 9, 4, 0. Okay, so let's start row reduction. So we're going to multiply the top row by negative 1 and add. So top row stays the same. Multiply by negative 1 and add. 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 Same thing, multiply by negative 1 and add. 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 Okay, so let's see, what do we do now? Let's see, so let's multiply the, well, probably the easiest thing to do is I'm going to take this, okay, so I could, well, let me play this by the book. 0, let's take this row and multiply it by negative a fourth. Then I'm going to take this row, multiply by negative 8, and add to this. Multiply this by negative 8, that gives me plus 2, then add to this, I get 5. Multiply this by negative 8, that gives me negative 10, add to this, that gives me 15. So combining, I get that 5 times C3 is equal to 15. So that C3 is equal to 3. Coming up here, I see that C2 minus a fourth C3 is equal to 5 fourths. So C2 minus 3 fourths is equal to 5 fourths. So C2 is equal to 2. Coming to the top row, C1 plus C2 plus C3 is equal to negative 25. So C1 plus 2 plus 3 is equal to negative 25, and so C1 is equal to negative 30. So finally, at long last, we get our solution. So coming back here, there is our C1, C2, and C3. We just solved for C1, C2, and C3. And so that means that y of t is going to be equal to C1, which is negative 30, e to the t, plus C2, I get 2 e to the minus 3t, plus C3 was 3 e to the 2t, plus 30t, plus 35. And so that is the solution of this initial value problem. If you did this on your own and you changed the order of these three numbers, then of course these three numbers would have been mixed up, but the practical effect is that when you come out the other end, you should have the same solution that you see on screen right now.